And we're back once again. This will be our lecture on section 5.2. Getting very close to the end now. Not going to have much new theory in 5.2. 5.2 is just taking the methods we learned in 5.1 and extending them to systems of equations with more than two variables. It's very similar. That's why I'm not actually going to include any more slides than just this. We're going to delve right into examples. I will say examples in this can take a while, so you just have to be patient and move through it. So the first one we're going to look at is exercise 24. We have x minus y plus 2z equals 2. We have 3x plus y plus 5z equals 8. We have 2x minus y minus 2z equals negative 7. So, how do we go about solving this? So this is exercise 24. I have x minus y plus 2z equal 2. 3x plus y plus 5z equal 8. 2x minus y minus 2z equal negative 7. Well, when you're solving a system of linear equations in three variables, it's generally recommended to do elimination. It just seems to save you a little bit of time. I will go over how to solve it by substitution, but elimination usually works best. So the idea is that you need to reduce this down to a system of equations in two variables. So what you want to do is take the equations in pairs and add them together in such a way that you cancel out the same variable. So for example, this is conditioned pretty well for this. So I could say add R1, row 1 plus row 2 here, and I get 4x plus 7z equals 10. I canceled out the y, and I could also do R2 plus R3, row 2 plus row 3. I would get 5x plus 3z equals 1. Now you've got two equations and two variables. Well, we know how to solve these, either by substitution or elimination. I would think it's really about 6 of one, half dozen of the other. I'll take the top one times negative 3 would get me negative 12x minus 21z equal negative 30. And the bottom one would be, see, I want to get to 21, so I had to multiply by 7. So 35x plus 21z equals 7. So I end up with 23x. I think that's right. Yeah, 23x equals negative 23. So x equals negative 1. Okay, once you found one, then you want to work backwards. So I found x equal negative 1, so I substitute into one of my equations in two variables. Doesn't matter which one. So 5 times negative 1 plus 3z equals 1. So negative 5 plus 3z equals 1. So 3z equals 6. Z equals 2. Then you take both of those and substitute back into one of your 3 variable equations. So take x minus y plus 2z equal 2. Take x as negative 1 minus y plus 2 times 2 equals 2. So negative y plus 3 equal 2. Negative y equal negative 1. Y equal 1. So our solution should be x is negative 1, y is 1, and z is 2, an ordered triple. You can check that same way as ever. Just plug it in. Negative 1 minus 1 is negative 2, plus 4 would be 2. Negative 3 plus 1 would be negative 2, plus 10 would be 8. Negative 2 minus 1 would be negative 3, minus 4 would be negative 7. Yeah. If you want to do substitution, because this was elimination. And of course we're solving the system. I didn't actually say that, but solving the system of equations. Substitution, we would be looking at getting one of the equations and solving for a variable. So like I'd solve the first one for x. I would have had x equal 2 plus y plus 2z. What do I do with that? I plug into the other two. So I have 3 times 2 plus y plus 2z plus y plus 5z equals 8. So I get 6 plus 3y plus 6z plus y plus 5z equals 8. So I get 7y. No, I'm sorry. I get 4y plus 11z equals 2. Say plug that into the other one, so 2 times 2 plus y plus 2z minus y minus 2z equals negative 7. So that's 4 plus 2y plus 4z minus y minus 2z equal negative 7. It'll be 2y minus y, so y, and 4z minus 2z, so plus 2z, and then subtract the 4 over would be negative 11. So you have y plus 2z equal negative 11. Might as well do that by substitution as well. So y equal negative 2z minus 11. So take that and plug it in there. 4 times negative 2z minus 11 plus 11z equal 2. That's negative 8z minus 44 plus 11z equal 2. So that would be 3z equal 46, I would guess is what that would say. And you get z equal 46 over 3, which is obviously wrong. I would have found it when I did my check. I see what I did. I see it. 2 plus y minus 2z. So that would make this to fix quite a few things. So that's a minus. I can probably just change the addition sign. that would be a minus 6z, which plus 5z would be a negative 1z. Which is minus z. And then down here be minus 2z, which would make it minus 4z, which would make it minus 6z, which should make it plus 6z minus 11. Alright, we're getting there. Six z minus 11. So that would get me 24z. Oh, I really ought to just erase that whole bit. Yeah. So, yeah, there's going to be very little correct about that. So, minus z equals 2. So 24z minus 44 minus z equal 2. So that'll be 23z equals 46, and then z equals 2. Yes, indeed. And then I just take that and plug it into one of my two variables. So y equals 6 times 2 minus 11, which would be 1. And then x equals 2 plus 1 minus 2 times 2. So that would be 3 minus 4, which would be negative 1. And we get the same solution. For that one, I was actually fairly lucky to be able to find my error. It's really easy to make errors on these things, and it's hard to locate them. So often on tests, as long as you go through the whole process and check your answer at the end, I will give you almost full credit, if not full credit. Just because I understand it's easy to drop a sign somewhere or make some other error. Notice here, all I did was drop a sign and it threw off my answer, so be careful. We're going to look at exercise 32. Here we have x minus 2y minus 3z equal 5, 2x plus y minus z equal 5, and 4x minus 3y minus 7z equal 5. So, looking at this, last time I did elimination and I used the y's. Honestly, the y's look pretty well conditioned for that this time as well. But just for variety, I'll take out the x's first instead. So, if I use this one as my kind of key function, let's take it times negative 2 and add it to this one. So, negative 2r1 will get me negative 2x plus 4y plus 6z equal negative 10. Then we got 2x plus y minus z equal 5. So that would get me 5y plus 5z equal negative 5, or y plus z equal negative 1, dividing everything by 5. And then how about this one? And let's take negative 4 times row 1. Negative 4 4x plus 8y plus 12z equals negative 20. I got 4x minus 3y minus 7z equal 5. So that'll get me 5y plus 5z, z, not y, Paul, z equal negative 15. And if I divide everything by 5, I'll get y plus z equal negative 3. You might actually be able to see where this is going to go already, but if I now say take this one times negative 1, I'll get negative y minus z equals 3. Add those together, I get 0 equal 2. No solution. Honestly, problems with no solution are probably the shortest system of equation problems, especially for systems with 3 or more variables. But we're done. So now we're going to look at 33. We're going to probably just do x's again, just because I've already got them so close to each other. So let's say take the first one times a negative, so I'd have a negative row 1, so sorry, negative x minus y plus z equals 0. Then I have x plus 2y minus 3z equal negative 3. Add down, you get y minus 2z equal negative 3. And then I guess it doesn't really matter, but take the top and bottom one, negative 2r1. So that would get me negative 2x minus 2y plus, by the way, always make sure you cancel out the same variable. If you think it's like easy, oh, it'd be easier to cancel out z with the other one, that won't get you anywhere. The whole point is to pick pairs and cancel out the same variable so you get down to the same type of two-variable equation. If you have one that's in x and z and the other's in y and z, you're no better off than when you started. So make sure you think about that. Plus 2z equals 0. And then I've got 2x plus 3y minus 4z equal negative 3. Add down, and you get y minus 2z equals negative 3. Notice they are the exact same equation. So if I multiply this one times negative 1 and add to that, I'm just going to end up with 0 equals 0. Well, that means we have an infinite number of solutions. And there's several different ways we could write them. It depends on which variable they want to be arbitrary, because if x is arbitrary, we could write 1. If y is arbitrary, we could write 1. If z is arbitrary. Usually they ask for x or z. So let's actually deal with z first. Y equals 2z minus 3. So if z is arbitrary, then y is 2z minus 3. And x, well, I just got to solve for it. So x equals z minus y. Yep. So x equals z minus, and then y was 2z minus 3. So z minus 2z minus 3. Because you should write all your variables in terms of just a single one. It says only one should be arbitrary. So z minus 2z would be negative z plus 3. So for example, if z was 0, we would have negative 3 just double checking. 3 minus 3 and 0. 3 minus 6 would be negative 3 minus 0. And then 6 minus 9 would be negative 3 minus 0. So yeah, this should work fine. If y was the arbitrary one. Well, honestly, once you get one of these solutions, it's not hard to get the other ones because you can just use the expressions you've got. You know, y equals 2z minus 3. So, let's see. 2z equals y plus 3. So z equals y plus 3 over 2. So straight off we've got y plus 3 over 2 in the z coordinate. We've got y. And then the x coordinate, x equals negative z plus 3. So negative times y plus 3, so negative y over 2 minus 3 over 2 plus 3 would be negative y. Well, negative 3 over 2 plus 3 would be 3 over 2. Negative y plus 3 over 2. So negative y plus 3 over 2. And if x were arbitrary, honestly, you can just use the other expressions at that point then. So x equals negative z plus 3, so z would equal negative x plus 3. And the y coordinate, I'll just probably use this one down here. X equals negative y plus 3 over 2. So 2x equals negative y plus 3. So y equals negative 2x plus 3. And let's just verify these solutions actually work, give the same result. If you plug in 3 for x here, you get 3, and then negative 6 plus 3 would be negative 3. And then negative 3 plus 3 would be 0. Okay, that's right. If you plug in negative 3 in for y, you get 0 in that coordinate. And you get negative of negative 3, so that'd be positive 3 plus 3. Be 6 over 2 would be 3. So yeah, they all give the same solutions. So any of these three I would accept, generally on a test. But generally the problems ask for a specific one. Like I say, they'll say let the z coordinate be a or the x coordinate be a and work from there. I'm just showing you all three. I would take any of them. And I do check for all of them on tests. The application problems are not significantly different, so I'm not going to do a bunch of them. I figured I would do problem 42 here. Gas station sells 3 types of gas, regular for $3, performance plus for $3.20, and premium for $3.30. So let's say, it should show up on my sheet as well. Oh yeah, how many gallons of each type? So R for regular. I need premium and performance plus. So how about P for performance plus? And B for premium. So what did they give us? They gave us a total for how many gallons were sold. Well, that's an equation. R plus P plus B equals 6,500 gallons. They told us the total money that accumulated. Well, that's another equation, because we have $3 for each regular gallon, so 3R. We have $3.20 for each Performance Plus, so 3.2P. And we have $3.30 for Premium, so plus 3.3B equals 20,20050. And then the last equation is going to come from here. 3 times as many gallons of regular as premium gas were sold. So regular equals 3 times premium, which was B. Alright. From that, we ought to be able to solve. I'm probably going to use a combination of substitution and elimination. Since they gave me R is 3B, I'm just going to plug into my other 2 equations with that. So 3B plus here I just get P plus 4B equals 6,500. So that's something. Here, 3 times 3, oh, I know what that would be. That would be 9B there, so 9B plus 3.3 would be 12.3, so 3.2P plus 12.3B equal 20,050. Yeah, because 9B plus 3.3. Honestly, I think I might rather do substitution all the way. I think it's going to be a hassle to get the... I mean, I could get this to work out by multiplying both by 3.2, or multiplying this by 10, and then multiplying this by 32, but it just seems simpler to do substitution. 6,500 minus 4B. So 3.2 times 6,500 minus 4B plus 12.3B equal 20,050. So I've got I don't think it's on anymore. There we go. 3.2 times 6,500 and 20,800 minus 3.2 times 4 would be 6.4, 12.8, 12.8B plus 12.3B, 20,050. So that would be negative 0.5B equals, well, it'd be 800 minus 50, so it'd be negative 750. And then divide by negative 0.5, that's the same thing as multiplying by 2. But divided by 0.5 is the same thing as multiplying by 2. Because dividing by 1/2, take reciprocal and multiply. So B equals 1,500. So is that reasonable? We have 6,500 gallons. Yeah, that seems reasonable. So B equals 1,500. And let's see, what do we have? We had R equal 3B, so R equal 3 times 1,500, which would be 4,500. And we had P. Well, I guess I could use it right here. P equals 6,500 minus 4B. Which would be 6,500 minus 4 times 1,500 would be, that's actually 6,000, so that would be just 500. So let's see if that makes sense. 4,500 plus 500 is 5,000 plus 1,500 is 6,500. So that checks out. And let's see, R equal 3B. I think that, yeah, that one checks out. How about this one? 3 times 4,500 plus 3.2. I think that was the 500, wasn't it? Yeah. Times 500 plus 3.3 times, what was that, 1,500? Yeah, 1,500. 20,050? 20,050. That is the correct answer. Alright, that'll finish us on this section. So if you have any other questions, you can make sure to contact me. I'll be glad to help you out. We generally only have one more plan section left in the chapter, but you'll be able to see how many sections just based on how many videos there are. Next, generally you can move on from this to talk about systems of nonlinear equations when you have several equations that aren't necessarily all lines. Generally, sometimes you can still do elimination, but a lot of times you have to do substitution for those just by their very nature. The problem with that is that in those cases are when you get more than one solution. If you have a finite number of solutions, because every finite number we've seen has just been one. That's the nature of lines, but if you have a finite number of solutions and your equations are nonlinear, it is definitely possible to get more than one solution. But then we go to systems of inequalities, which are a little bit different. We'll be looking at those, definitely. So I will talk to you in the next lecture. See you then.